Hi, in a previous tutorial we saw that if y is equal to sine ax plus b, then dy by dx is going to be equal to a cos ax plus b. Now we know that differentiation and integration are two operations that reverse each other. So it follows that if I were to integrate both sides with respect to x as follows, dy by dx, with respect to x it must be equal to the integral of a cos ax plus b with respect to x. The coefficient of this quotient here is equal to 1, and the integral of this left hand side is essentially just equal to the integral of 1 with respect to y is going to be equal to, I can factor out this real number here a and say that it's equal to the integral of cos of ax plus b with respect to x. Now the integral of 1 with respect to y is going to be equal to y plus some integral constant with which I'm going to call c, and it must be equal to the integral of cosine of ax plus b with respect to x. I already know what the value of y is equal to. Y is my starting function here, which is sine ax plus b plus some integral constant c, which is going to be equal to a integral of cosine of ax plus b with respect to x. Now I can divide both sides by this constant here, and so I'm going to have 1 over a sine of ax plus b plus c over a, and it's equal to the integral of the cosine of ax plus b with respect to x. Now you'll notice that I have an integral here on this side, so what we've actually managed to show is that the integral of, I can write it on this side here, the integral of cos of ax plus b with respect to x is equal to a 1 over a sine of ax plus b. Now if I let c over a equal to some other constant, any real number, if we redefine it and say plus k, then we have found what the integral of cos of a x plus b with respect to x is going to be equal to. Now if we argue along the same lines and we are given that y is now equal to the cosine of ax plus b, then my dy by dx is going to be equal to minus a sine of ax plus b. Integrating both sides as before means that on the left hand side I'm going to have y plus some c is going to be equal to minus a multiplied by the integral of sine ax plus b with respect to x. But we know that y is equal to the starting expression here, so if I replace that with my initial value, it'll be cos of ax plus b is going to be equal to, plus the integral constant c is going to be equal to minus a, the integral of sine ax plus b with respect to x. Dividing throughout by the negative a means that we have minus 1 over a cos of ax plus b plus c is going to be equal to the integral of sine ax plus b with respect to x. And of course the c is also over minus a. Now making a bit of some space here, and I'm going to redefine, if I let minus c over a, this here, if I redefine it and call it k, then it follows that the integral of sine ax plus b with respect to x is just going to be equal to minus 1 over a cos of ax plus b plus some integral constant k. So what remains then is for us to put into practice these results that we have derived. I have here 3 questions that I would like you to attempt on your own, and then play back the video once you've finished and compare your solutions against mine. You may pause the video now. Welcome back. Let's dive straight into the solution of the 3 questions. So as before, the first thing that we want to do is integrate sine. So from our result here, we found that the integral of sine is going to be negative cosine. So I'm going to write minus cosine of the same angle, pi over 2 minus 5x, and then we differentiate this angle here, and the derivative of pi over 2, which is a constant, is going to be equal to 0, and the derivative of minus 5x is going to be equal to minus 5. So we divide by minus 5, which is the same as multiplying by minus 1 over 5. Okay, and let me put a square bracket around that, plus the integral constant. So simplifying that means that we've got 1 over 5 cos of the same angle, pi over 2 minus 5x plus k, and so that would be your integral. Doing the same thing here, I'm going to keep the 2 as a constant, which is going to multiply everything that comes after that. Multiply by the integral of cos, it's going to be equal to positive sine of the same angle, which is 3x, and then we'll find the derivative of the angle, which is 3, so we put it as 1 over 3 plus some integral constant k. Tidying this up again means that the result is going to be 2 over 3 sine of 3x plus the integral constant. And finally, we'll look at this question 3. There's a coefficient of negative 1 here, so we'll put minus 1. Find the integral of cosine, which is positive sine. The angle is maintained, it's 2x minus 1. And then we're going to divide by the derivative of that angle, which is 1 over 2, plus obviously the integral constant k. And that is going to be equal to minus 1 over 2 sine of 2x minus 1 plus the integral constant k.